So I know we are already talking about graphs in the last video, but here it's going to be more of a conceptual development and a conceptual unloading of these problems. So let's start just with example 3. Consider this unlabeled graph. All right, you got one function that looks like this. Well, let's color code these actually. That'd be a good idea. Let's say one function that looks like this. And another function. It's also an exponential function that looks like this. These are two exponential functions. Part A. If both of these functions, let's label this F, label this G. Both functions have the form y equals a times b to the x. Again, a is that starting value. B is that growth or decay factor. It's growth if b is bigger than 1. If both functions have this form, which has a bigger a? Well, if a is the initial value, a is the y-intercept, well, this is G's y-intercept. This is red's y-intercept. Which one's bigger? Well, G's. G has a bigger a. That sounds weird. G has a bigger a. Yes, okay. Part B. Now, which b value is bigger? B is the growth rate. Even though G starts out bigger when x is equal to 0, notice G is growing pretty small. F has a much steeper slope, right? F is increasing much more quickly. F has the bigger growth rate. All right, let's do another one. All right, this next one, we're going to have a little secret again. I'm going to go over here. I'm going to plot a mystery function. A mystery function over here for you. All right, let's look at this function together. And I'm going to ask you, could this function be 3 times 2 to the x? Sorry, just losing my mind real quick. No problem. This is example 4. Part A. Could this function be 3 times 2 to the x? Right off the bat, the answer is no. 3 times 2 to the x, right? That would have a y-intercept of 3. And a growth rate of 2. Or growth rate, growth factor. But right off the bat, I can see the y-intercept is positive 2. So it can't. Nope, our graph has a y-intercept of 2. Nah. And in fact, we could actually come up with a full equation. Let's keep investigating with this logic. Could this function be y equals 2 times 1/2 to the x? Well, this has the right intercept, right? The y-intercept is 2. Our y-intercept is 2. The problem is, this right here is decay. We're decaying by 1/2 every time we increase x, but no, that's not happening. We're growing. Nope, ours is exponential growth. So I just want you to kind of apply this logic to some of these problems. All right, and that's basically all this video is. I want to briefly mention, we'll do the full problems in the selected homework problems video, but I want to briefly mention a couple homework problems because you see things like this on the homework and you say, that's so many curves. And it asks you some questions about it. All right, let's start with this one, which is also just as bad, if not worse. It wants you to match each function with the graph. But notice that we have numbers here, but we don't have numbers here. Oh goodness. So what it wants you to do is use comparisons, right? The first couple have a starting value, a y-intercept of 2. But some of them have 4, right? So 16 and 18 have to be either C or D, right? They have a bigger y-intercept, a bigger starting value. You use this thought process. And then which one's 16 and which one's 18? Well, C is the one that's decay. So C has to be 18 because 18 is decay. The B value is less than 1. So use this thought process. Look at the growth rates relative to the other candidates. Look at the starting values, the y-intercepts relative to the other candidates, and you should be able to match these ones. All right. Similarly over here, this is doing basically the same thing that we did in the last example. Compare growth rates, compare starting values or y-intercepts. For example, C has the biggest y-intercept, so it has the biggest A value, and so on. And one more honorable mention, number 46, for this video. Use a graphing calculator to approximate the solutions. If you just graph both sides of this equation, and again, I'll do this full problem in 6.2.4. If you graph both sides of this equation, you'll find the solution. So good luck. Let me know if you have questions.